Hey, welcome to Ultrabolt, your power station for game dev magic. I've just released a brand new update for BrainsAI. This is version 2, and it's not just a small patch. I've completely rebuilt the system from scratch, fixing a lot of issues from the previous version and making everything faster, smarter, and way more flexible. This update brings new features, new brains, and a smoother workflow overall, and making it easier than ever to create intelligent AI behavior in your Unity projects. I'll show you everything about this package and how to get started with your own models, so grab your coffee and let's go. Now let's talk about the brains. In this version, there are 6 built-in brains. And of course, you can create your own, which means the possibilities are unlimited. What's really cool is that all these different AI characters are powered by just one single script. Everything is fully editable and customizable directly from the inspector. So allow me to walk you through the inspector and show you how this system works behind the scenes. Let's start with the brain type. This defines how your AI behaves when interacting with a target. There are 3 main types: Engager, Ranger, and Coward. The Engager brain will chase the target and stay close, perfect for melee enemies or aggressive units. The Ranger brain also chases the target but always keeps a distance, ideal for enemies that use ranged weapons or spells. And finally, the Coward brain does the opposite. It constantly tries to run away and keep as much distance as possible from the target. Next, we have the communication settings. This section controls how AI agents can alert each other when they detect a target. You can enable draw alarm gizmos to visualize the alarm radius directly in the scene view. Super helpful for debugging and adjusting ranges. The alarm radius defines how far this agent's alert can reach. Any other AI inside this radius can receive the signal. Then there's the group name, which defines what team or faction this character belongs to. For example, enemy or companion. And finally, the alarm groups list defines which groups can hear this agent's call. In action, this means that when one AI spots a target, it can call others nearby by invoking the call agents method, basically shouting, "Hey, we've got a target," and every agent in the same alarm group will immediately react. Now let's move on to the movement settings. This section controls how fast your AI moves and how it behaves while chasing or patrolling. There are 3 main speed types: walk speed, used when the character is patrolling or just moving casually; run speed, used when the character is chasing a target; and sneak speed, used when the AI loses sight of its target and starts investigating the last known position. Then we have a vector 2 called move range. This defines 2 important distances: the stopping distance and the lose distance. For example, if the character's brain type is Ranger and the target crosses the X value, the AI will retreat to keep a safe distance, but if the target moves beyond the Y value, the AI will start chasing again. You can also enable draw movement gizmos to visualize these behaviors directly in the scene view. In the scene view, you'll notice a purple circle gizmo showing this range. That's the area where your AI will stop or resume chasing, depending on the target's position. Now let's take a look at the jump settings, one of the brand new features in version 2. This system allows your AI agents to use nav mesh links combined with animation curves to perform smooth, realistic jumps. The jump curve controls the shape of the jump over time, basically how the character moves along the y-axis from start to finish. The jump height defines how high the agent will jump, and the duration multiplier affects how long the entire jump takes. What's really smart about this system is that it automatically adapts to the distance between the 2 points, meaning a larger gap will naturally take longer to reach the other side compared to a smaller one. This gives your AI much more dynamic movement, especially when navigating uneven terrain or jumping between platforms. Next, let's talk about the field of view. This is a separate script that's automatically added to your character's head as a new game object. It allows the AI to actually see targets within a specific radius and angle, just like a real vision cone. In this version, the entire chasing and investigating behavior has been moved to this script. That means the AI's actions are now fully based on what the character can actually see, making everything feel much more realistic and dynamic. There's also a brand new feature called Awareness Scale. This adds a smaller black field of view behind the character, allowing it to detect targets that get too close from behind, even if they're outside the main vision area. And finally, we have the Investigate Duration. This defines how long the character will keep searching for a target after losing sight of it before returning to its normal state. Now let's move on to the patrol settings. This section controls how the AI moves around when it's not chasing or attacking. When patrol is enabled, the agent will automatically start patrolling, either between predefined waypoints or randomly within a certain area. You can also enable draw patrol gizmos to visualize the yellow patrol range directly in the scene view, which makes setup much easier. If you assign a patrol path reference, the AI will follow those waypoints in order. But if you leave it empty, the AI will simply patrol randomly around its current position, perfect for guards or creatures that wander freely. The patrol radius defines how far the agent can move from its starting point when using random patrols. And finally, the standing time is a vector 2 that defines the minimum and maximum idle time between patrol points, so your AI can pause for a moment before continuing its route, making the movement feel more natural. And finally, we have the attack settings. This section controls how your AI handles combat and damage behavior. When an attack is enabled, the agent is able to perform attacks using random animations, random damage values, and random cooldown times, making each fight feel a little different. The attack call type defines how the attack is triggered. You can choose between automatic or external. When set to automatic, the attack method will be invoked automatically as soon as the attack animation plays. Perfect for simple setups where you want everything handled by the system. But if you choose external, it gives you full control. You can manually trigger the attack through an animation event, a custom script, or even add your own delay before applying damage. You can also control how many attacks happen per cycle using max attacks, and define random damage using the damage range and attack time values. Together, these options make your AI combat flexible, dynamic, and fully customizable to match your game style. Of course, this is not where it ends. In BrainsAI, there's also a new type of brain that inherits directly from the main brain script, called the tactical brain. This brain uses the same core features and settings as the original, but behaves differently when chasing a target. Instead of rushing in, it will hide in the safest nearby spot, usually close to cover or the edge of the environment. After a short delay, it will peek out and attack from the most secure visible position, giving your AI a more realistic and tactical combat style. In the inspector, you'll notice only two new fields: hiding time, which defines how long the character stays behind cover, and visible time, which controls how long it stays exposed before hiding again. One important note: make sure to place your tactical characters in environments with plenty of objects or obstacles to hide behind. And it's also recommended to increase their FOV radius so they don't lose sight of the target when retreating to cover. Now, you might be wondering, how does this brain actually know which spots are safe and which ones are visible to the target? Well, that's all handled by a script called Tactical Spots. This system generates a 3D grid of potential positions using raycasts from the target's point of view, and then aligns them with the nav mesh surface. You can adjust the agent height and the hide depth to control how deeply the character hides behind cover, depending on your scene setup. There's also a resolution setting for the 3D grid. Increasing it creates more points and results in more accurate, realistic behavior. However, keep in mind that higher resolutions can be more performance heavy, especially on large maps. In this example, I'm using a light source as the target, so you can easily visualize how it works. The shadowed areas represent safe zones, while the bright lighted areas are considered danger zones. This gives your AI the ability to make smart tactical decisions using actual visibility data from the environment, and that's it. Now that we've covered all the brains, let's move on to the additional scripts that come with BrainsAI. The first one is the alarm emitter. Remember how characters can call nearby agents for help? This script works exactly like that. It lets you trigger an alarm and alert specific groups of agents, or even all of them at once. When activated, it calls every brain within the defined alarm radius, making it perfect for things like explosions, traps, or distractions. You can also choose to invoke the alarm automatically on enable, meaning the moment this object becomes active in the scene, it will instantly alert nearby agents. It's a simple but powerful way to create coordinated AI reactions in your game world. Next, let's talk about the patrol path script. This tool allows you to easily draw patrol paths and assign them to any brain, so your AI can move along a predefined route. The script itself has only one main setting: loop path. When enabled, the character will continuously walk in a loop through all the waypoints. If it's disabled, the agent will move back and forth between the first and last points. What's really smart is that each brain automatically starts patrolling from the nearest point on the path, not necessarily the first one, which helps keep things smooth and dynamic. Now, here's how to draw a patrol path in the editor. Shift plus click on the nav mesh surface to create a new waypoint. You can also Shift plus click between two existing points to insert a new one. Each point automatically snaps to the nav mesh, so it will always stay within navigable areas. To remove a point, Control plus click on it, and to move a point, just click and drag to reposition it freely on the nav mesh surface. This makes creating patrol routes extremely fast and visual, perfect for setting up guards, animals, or any kind of patrolling AI. The next script is called Staring Script, and it's a small but powerful addition that gives your AI a much more realistic touch. This script automatically makes the character's head smoothly rotate to look at its current target, based on data from the FOV system. It works directly with the humanoid head bone and smoothly interpolates the movement to avoid any snapping or sudden rotations. You can also add a small rotation offset to adjust the head tilt and control how quickly it rotates using the rotation speed value. value. The script even respects the character's view angle, so if the target moves outside of that range, the character simply looks forward again instead of twisting unnaturally. In short, this script helps your agents feel alive. They don't just react through behavior, they actually look at what's happening around them. And lastly, the brain controller feature. You can instantly take control of any character that uses a brain script and control it just like a player. There's a small script attached to the camera that waits for you to click on any brain character in the scene. When you click, it automatically adds the brain controller component to that character. From that moment, all brain decisions are disabled and you take full control. The camera will automatically follow the controlled character. If no brain is being controlled, the camera simply stays in place. Once you're in control, here's how it works. Right-click anywhere to walk. Hold the control key while right-clicking to run. Hold the shift key while right-clicking to investigate. Left-click to attack. Press the A key to call the nearby agents. Press the escape key to stop controlling the current character and select another one. This feature is perfect for testing your AIB. That's everything you need to know about BrainsAI. There's a lot more packed into the package: custom inspector helpers, gizmo utilities, gameplay helper methods, and I made a full step-by-step documentation that covers everything. I commented and added tooltips to every script so you can quickly understand how each part works and where to start if you want to customize or extend the system. Also remember, you can reuse any part of BrainsAI in your own projects. For example, the FOV system is great to adapt for security cameras or other non-AI systems. It wasn't created only for the brains. Thank you for watching, and if you try BrainsAI V2, I'd love to hear your feedback or see what you build with it.